Hello, everyone. Welcome to Lecture 1 on Introductory Statistics. Now, in this lecture, we're going to give a basic introduction to statistics. We're going to introduce several very important concepts in statistics. All right, let's firstly talk about Section 1 in Chapter 1. Right? What is statistics? All right, here I give a definition here. Now we say statistics is a science that deals with study planning, data collection, organization, analysis, interpretation, and presentation, and then draw conclusions based on them. So what is statistics? Now, statistics involves many aspects. All right, so you got to plan the study. You got to collect the data, right? Data collection, data organization, data analysis, data interpretation, how to interpret your data, and then data presentation, how to present your data, right? And based on after you're done with all this, and then you have to draw conclusions based on all these, based on these studies. All right, so it has many aspects. Okay, so in statistics has been used in virtually all scientific fields. All right, and research questions in various scientific fields motivate the development of new statistical methods and theory. Now, this is very common. All right, this is, even though statistics has been around, it's a more recent subject. Right, it has been about 6 to 7 decades here, but even during this short period of time, it has been used in almost every scientific fields. Just think about it. Like here I give in biology, economics, finance, engineering, and so on, right? So there are just so many areas that use statistics. And also, in the other way around, in the research questions in other scientific fields, all right, motivate the development of new statistical methods and theory. This is also very common, all right, especially these days. When we talk about the image, the deep learning, all right, or artificial intelligence. Now, the computers has to what? Read images, image processing, right? So for a computer to read an image, it has just a really huge amount of data out there. So for traditional statistics, it doesn't work well. So you have to what? Deal with high dimensional statistical analysis. All right, so this is a comparatively very new area, or a high dimensional analysis. Okay, so as you can see, I just give several examples here. Now, just so you know, that statistics as a science subject, right, involves many aspects, and it is closely related to the development to other fields, other scientific fields. All right, so that's statistics. Now here I give some examples here. So you have biostatistics these days, right? So biology plus statistics. All right, that's biostatistics. Econometrics, all right, that's economy and statistics. All right, econometrics. Of course, you have engineering statistics as well for different aspects of engineering, right? So like the in the road and the bridges and the building and so on, right? You do the civil engineering, and you need a lot of data. And also in traffic use a collision, right? So collision analysis. In the just imagine that in the car, right? So there are always accidents in each day. Happens every day, right? So how often, how these accidents are related to the features of our road, and so on. Now in engineering, you also have mechanical engineering, right? So like if you design an engine, what is efficiency, the fuel efficiency of the engine? That's huge, right? That's very, very important. Now you can see that all of these, in these scientific fields, they need data. They need to do data analysis. All right, that involves study planning. You got to collect the data and do all data organization and analysis and how to interpret your analysis, and then give a presentation, right? So you got to do a report to your audience. This is our funding. Now, this is statistics, right? Statistics used in these areas. All right, so next, all right, we also have here is image processing, right? So image processing, this is really a really new area, all right, recently, especially with the development of deep learning. Image processing now it has been closely related to statistics, right? Now they are, when we do the computer sees the image, it is arrays of values, not like our we do, right? We see an image as a picture here, with different colors, different shapes, and so on. But when the computer sees an image, it is an array of data, values, numerical vectors, or so on. So it is dealing with a lot of data. Okay, so of course, as in this image processing, it motivates, all right, the new areas of statistical methods and theory. For instance, this is the high dimensional analysis, right? When we talk about the image, it can be thousands of data in one single image, So that's really high dimensional. Okay, so this is going to be some new area in statistics. Okay, and other areas like information science, all right, and psychological statistics, and etc. Right? So it is just so many different scientific fields out there. They are involved with statistics, and it grows and develops together with statistics. All right, so that is a picture of statistics. All right, what is a statistics and how statistics relates to other scientific fields? All right, so now let's consider a simple example to illustrate statistics. All right, what do we do in statistics? All right, so this is a very simple example. Now assume that we are to find out the average weight in pounds of all newborn babies from January 1st, 2000 to December 31st, 2010 in a big country such as the United States, right? So what shall we do? All right, this is the question we have. What do we want to do? We want to find out the average weight of all the newborn babies during this time period in a big country like the States. All right, so what shall we do? All right, so here we know what we want to get, right? So average weight. Now, question here is, in order to find the average, all right, as we know, we can take the summation, right? All the newborn babies, and take the summation and divide it by the number of newborn babies during this time period. And then we got the average. That's basically what we usually do, right? To find the average of a set of number, we just add them up and divide by the number of numbers here, the number of values here. That's how to find an average. But for this particular example here, question is, can we obtain the weights of all newborn babies? It's going to be, sometimes it's just going to be too much, right? All right, so it's just maybe it's just impossible. All right, it is impossible, right? And some there are just too many newborn babies. All right, so there are too many. Okay, too many newborn babies. You do not have that amount of time or resource to get all these weights. And secondly, maybe go to some legal issues, right? Because due to privacy, it's hard to get. All right, and it's just too many, and also it's hard to get. All right, so because there are maybe some legal issues out there for privacy, right? You cannot get the data out there, right? And the reason this reason can go on, right? So it's just seems like impossible. All right, it's just impossible. All right, can we obtain the weights of all newborn babies during this time period? No. All right, we can safely say no. All right, no, you cannot. Now here, if not, what would be a practical approach? Then we cannot get all the weights of all newborn babies. Then is there a way around? So what would be a practical approach? You got it. All right. So a practical approach is going to be take a random sample. All right. So here we have. It would be impractical to obtain the weights of all newborn babies during this time period in this big country. Instead, all right, a practical approach is to randomly select a certain number of such newborn babies in this time period. All right, so let's randomly select a certain number of such babies. For instance, you randomly select 1,000 newborn babies, 1,000, right? That's relatively large and not small, right? So okay size, right? 1,000 newborn babies, and it's doable, right? For you cannot get all the weights, but you can try to get 1,000. I say that, right? And then based on this sample, all right, of this number of randomly selected newborn babies, you can find out their weights and also find out their average. All right, and then we find the average weight of these selected babies and use it. All right, here we use it as a plausible guess of the average weight of all such newborn babies. So that is a practical approach. You cannot get the weights of all newborn babies. Now what we can do is we can obtain a random sample of such newborn babies of a certain size and find out the weight, their average, right? The sample average, the average of the sample. And then we can use the average of the sample as a plausible guess of the average weight of all. Okay, you see, this is what we can do, right? Now, this is a typical statistical problem, all right, a statistical study. All right, so we have the following important concepts here. Now, one is what? Okay, here is all the newborn babies from January 1st, 2000 to December 31st, 2010 in this big country. All right, this number, this set is really huge, right? It's really large. This is big, large, huge, right? So there are just a lot of, or many subjects objects in this set. And contrary to that, we also have another set, all right, a certain number of such newborn babies selected at random. All right, so this is a sample. All right, we are going to discuss that. All right, so in statistics, we do have some basic terms, all right, to represent this. Let's see what they are. Now, we begin with some very basic definitions. Now, firstly, we talk about the population. Now, what is a population? All right, so this population is not a number of human beings in a certain area or certain region. All right, so here the population is a statistical concept. All right, a population is a complete collection of objects of interest under the current study. All right, be careful. It is subjected to a study. Okay, so a population is a complete collection of objects of interest under the current study. Like in this one, all right, in this example, we're trying to find out the average weight in pounds of all newborn babies from this time period and in this big country, right? So therefore, the population here is going to be all newborn babies during this time period in this country. Okay, that's the complete collection, all right? Complete collection of objects of interest. Okay, that is a population. All right, so now, in contrary to with population, we have another concept, all right, called a sample. All right, what is a sample? Okay, a sample is a subset or subcollection selected from a population. We just say selected. It doesn't have to be randomly, all right? So as long as it is a subset or subcollection from a population, then it is a sample. Okay, so later on, we are going to talk about the random sample and other samples. But just to be careful here, a sample is, by definition, is just a subset or subcollection of a population selected from a population. All right, so that is a sample. Now, in this example, right, so in this practical approach, we randomly selected a certain number of such newborn babies. So this certain number of such newborn babies, all right, is a subset from the population, right? So it is a subcollection or subcollection from the population. So therefore, by definition, it is a sample. Okay, so that is what we mean by a sample. Okay, very good. Now let's consider now a special case for sample. All right, so a sample is called a census, right? If what? The sample consists of all objects in the population. All right, so if a sample is you are going to take a sample including all the objects in the population, then you have another name for this sample called census. Or basically, everybody or every objects in the sample has to be in the population, has to be included in the sample. That is called a census. All right, and in the States, we every 5 or 10 years, right? We do a census, right? Census survey. Okay, so they will collect the data on the number of populations, age, and so on, right? So to do a census every 5 or 10 years. Okay. Now, then we have population and sample. And now, all right. So we usually, all right, so are interested in some properties or characteristics of the of something about the population. Okay, so now those things are usually can be measured or can be represented as data. Okay, so for instance, here we are talking about the average weight. All right, some characteristic, some feature about the population. All right, and this weight is a measurement. Okay, sometimes these can be represented as data. Okay, so what are data? Now, data are a collection of observations. All right, so what are the observations? The observations such as what? Such as measurements, like the weight, like the height, like the volume, right? And speed, and so on. As a measurements, right? So you can use numerical measurements, okay? And attributes, and attributes, okay? So attributes will be something different, all right? So it's not numerical value, but for instance, the gender of the newborn baby, right? Male or female. It's not a measurement. It is attributes, okay? But here, data, these observations can be what? Can be measurements, or it can also be what? Attributes, all right? Just we're going to talk about these concepts later on, all right? So just remember, data are a collection of observations, such as measurements and attributes. It can be on a sample or a population. Okay, so now if the data are from a sample, they are called what? They are called sample data. Yes, the data can be on a sample or a population. Now, if the sample is for a sample, we call it a sample data. If this data are from a population, they are called population data or census data. Okay, so it's pretty easy to understand, right? So it's just depending on whether it is from a sample or it is from a population. If it is from a sample, then it's called a sample data. If it is from a population, then it is called a population data or census data. Pretty interesting, right? So, all right, now let's see another two concepts here, parameter and a statistic. All right, so this is also very basic and important definitions here. So what is a parameter? All right, so a parameter is a numerical measurement about some property of a population. All right, so be careful. This is about a population. All right, parameter is for a population. Right? It is a numerical measurement about some property of a population. Okay, like what we have here, right? So we want to find the average weight, all right, of all the newborn babies. Now, this average weight of all newborn babies, it is a numerical measurement about some property of the population. So this average weight is a parameter. Here is a parameter. It is a parameter, right? Because it is a measurement about some property of the population, right? So therefore, it is called a parameter. Now, what is a statistic? All right. So a statistic is what? Is a numerical measurement about some property of a sample. All right. Here is the difference here. So statistic is a numerical measurement about some property of a sample. Now, in this example above, all right, so we have what? We found out the average weight of these selected babies, right? So this average weight, you see, this average weight is a numerical measurement about what? Some property of the selected babies, which is a sample. So this average weight here, it is a statistic. It is a statistic. Okay. All right. So so we usually use what? Some a well-chosen statistic to estimate the value of a parameter. Okay, so for instance here, right? So we use this average weight of the selected babies, all right? So which is a statistic, and we can use this to estimate what? To estimate the average weight of all newborn babies, which is a parameter. Okay, so now of course you have to choose it. You have to choose some proper statistic. All right, some proper statistic. All right, so that is the several concepts here. All right, so we have population, we have a sample, and we can collect. We can have data. Data can be sample data or population data, right? And then we have parameter and statistic. Very good. All right. So now let's consider in the example above, right? So the population we already know, right? So all the newborn babies, the sample is a set of selected babies, all right? And the mean weight denoted by mu, all right, of the population is a parameter, all right? So here mu is a Greek letter. It reads as mu, all right? It's a Greek letter. The parameter is usually denoted by a Greek letter. All right. Now, the mean weight x bar, all right, x bar of the sample is a statistic. Okay, very good. All right, these are some very important concepts. All right, so just remember. All right, so a parameter is for a population, and statistic is for a sample. All right, so parameter is for a population. Okay, parameter for a population and a statistic a parameter. Our parameter is for a population and a statistic is for a sample. Okay, all right, so very good. All right, so now let's consider this example here. All right, so let's consider this example. For the following problems, decide if the situation is dealing with a population data set or with a sample data set, and explain your decision. All right, so let's consider the first. Mrs. Smith wants to do a statistical analysis on students' final examination scores in her math class for the past year. Okay, should she consider her data to be a population data set or a sample data set? All right, it's a population data set or sample data set. How do you think? Now, all right, it's a population data set or sample data set. Now for this one, you have to be careful. Let's check the definition. All right, so what is a population? A population is the complete collection of objects of interest under the current study. All right, so you have to be careful. The population is the complete data set, but all right, it is subject to the current study. Okay, so now let's see what Miss Smith want to do. All right, so here is her interest. She wants to do a statistical analysis on students' final examination scores in her math class. All right, so that is her interest. She is not trying to do a statistical analysis to all students besides her class, right? And it's just focus on her class. That's her study of the current study, right? Of Miss Smith's study. All right. So, so here we have a what? Does Mrs. Smith have all the data about every student in her class? Yes, right? So it is what? The population is all the students in her math class. All right. So she is the instructor. So she has all the data for all the students in her class, which is the population under this study. Okay. So this data is what from the population. All right. So therefore what? It is a population data set. All right. So here, it's a population data set. Okay, very good. All right, this is our first example. So be careful. You got to consider the current study. All right, the population is subject to the current study. All right, so second, let's consider this one. A group of students surveys 100 students from their freshman class to determine the number of pets in each student's household. The group plans to compute statistical findings on their data and generalize these findings to the homes of all freshman students. Should the group consider their data to be a population data set or a sample data set? Okay, for this example, it is a population data set or a sample data set. All right, for this one is what? It is what? It is a sample data set. It is a sample. Why? Why it is a sample data set? Okay, so because, all right, because they just surveyed 100 students from their freshman class, right? And also from this sentence, we know that, all right, they didn't generalize these findings to the homes of all freshman students. We can clearly see, right, that this 100 students is a subset or subcollection from the population, from all the freshman students, right? So therefore, this data is about 100 students, which is a sample. So therefore, this data set is a sample data set. All right, so very good. It's a sample data set. All right, sample data set, very good. All right, so let's consider, how about consider another example here? All right, so let's consider this one. In a survey conducted by the not.com, all right, 1,165 engaged or married women were asked about the importance of a bended knee when making a marriage proposal, right? So among these respondents, 48% said that bended knee is essential. Okay. Should the company consider that data to be a population data set or a sample data set? What do you think? As a population data set or sample data set? This is what? A population or sample? All right. So it is what? It is a sample data set, right? So it is a sample data set. Why? All right, why it is a sample data set? Okay. There are 1,165 engaged or married women were asked. So pretty much, a lot, right? There are many, right? So over 1,000, that's a lot. But still, even though it is over 1,000, it is still what? It is still a subset of all the women's, right? All the engaged or married women, right? So we can clearly see that this is a sample of the population, right? So because they cannot survey all the women, all the engaged or married women, right? They just surveyed 1,165 engaged or married women. So this data is about these surveyed women, right? Which is a sample. So therefore, the data is a sample data set. All right. So this one is again a sample data set. Okay, sample data set. Very good. Okay. Now let's consider 4. All right. So consider this one, a clerk wants to do a statistical study on family sizes in the county where she works at. She get all the family sizes from the county. Should she consider her data to be a population data set or a sample data set? Census? Okay, so what is that? Is a population data set or sample data set? All right, so this is what? This is a population data set, right? So this is a population data set because what? She get all the family sizes from the county, right? So now her interest is the family sizes in the county where she works at, right? So that's her interest. And she got all the family sizes from the county. So that is the data from each subject from the population, right? So therefore, it is a population data set, okay? Now, of course, is this a census? Yes, right? Yes, it is a census because that's the population. All the data from the population is also called a census, okay? So here is a population data set, right? Data set, and yes, it is a census. Is a census. Okay, very good. All right, so I hope that you already know these concepts of population and sample, and also you know the difference between them. Okay, so and here is what we do in basically in statistics. All right, so there are two branches of statistics. Okay, so one is the descriptive statistics. The other is inferential statistics. Now, what is descriptive statistics? Now, descriptive statistics is the branch of statistics that aims to describe the property of a sample. All right, properties of a sample. Okay, just to describe. All right, so like what is the mean? What is the minimum value? What is the proportion of certain attributes and so on, right? So just to describe. All right. So this is called a descriptive statistics. Another branch is called inferential statistics, and inferential statistics is a branch of statistics that aims to what? Make inferences about a population based on sample data. Okay, so this is something, all right? We want to make some inferences about a population based on the sample data, right? Like what we considered in this in the first example, right? So in the first example, what do we do? The practical approach is we randomly select a certain number of newborn babies, and what do? We use the information from the sample, the average weight of these selected babies, right? This is the information we get from the sample. And use this sample information, sample data, to what? To make a plausible guess of the average weight of all newborn babies. You see, this is the difference, right? So we are using something known about the sample to make a prediction, to make some inferences about something unknown about the population. Okay, so this is called inferential statistics. Okay, well, descriptive statistics is simply what? Simply find the average weight. What is the average weight of the sample? It's just to describe the property of a sample, right? Well, the inferential statistics is trying to what? Make inferences about the population based on the sample data. Okay. All right. Okay, here is the interesting paragraph, interesting figure here. So you can see there, this is the population, right? Which is a lot, all right, a lot of objects. Now using sampling, we can take a sample, which is a subset from the population, all right? And then we got the sample data, right? The sample data. So it's the collection of observations from a sample, right? We got the sample data from the sample. Like say x1, x2, xn, all right? And these are the sample data. And then the two branches, all right, the two branches of statistics. Descriptive statistics, what does descriptive statistics do? It's just to study the properties of the sample data. Okay, it's just to do the properties of a sample data. Now, another branch, okay, so inferential statistics is to make inferences about the population based on the sample data. Okay, that's inferential statistics. Okay, so now because populations are often very, very large, a common objective of the use of statistics, all right, be careful, is to obtain data from a sample. You firstly get the sample data, right? And then use those data to form a conclusion about the population. That's what inferential statistics. Okay, inferential statistics. Okay, so you firstly obtain data from a sample, all right, and study the sample is what descriptive statistics. But when you use the data to form a conclusion about the population, that is going to be inferential statistics. And in many cases, these two branches are both utilized. All right, you have to describe the sample data and also use it to make some inferentials. Right? In many cases, it is like this. Of course, in some cases, you only talk about descriptive statistic. Okay, so that's also possible. All right, but just hope you understand. All right, this is a typical statistical study process. Okay, so you firstly take a sample and then get the sample data, and then do some study the properties of the sample data, which is descriptive statistics. And finally, what? You make some inferential inferences about the population based on the sample data, which is inferential statistics. Okay, so that is a bigger picture of statistics. What do we do in statistics, right? What do we do in statistics? All right, so this is a basic introduction on statistics. Okay, now let's move on to the second section, which is about the sampling method. As we see, it's always involved with the population and the sample. And how to get a sample? That's what? Take a subset or subcollection from the population. Now, the question is, how can we do that? Right? So we have to be very, very careful, all right, when we are talking about the sampling methods. Now, why we do sampling? All right, why we do sampling? Well, it's often it's often impractical to collect data from a population. Population is usually huge, right? So it is a complete collection of objects of interest. So it's just often huge number of objects involved in the population. Now we also have what? We have limited source, such as time, money, etc. We cannot get data from all the objects in the population. So that's one of the main reasons why we have to do sampling. Okay. Now another possible reason is maybe some experimental studies sometimes have what? Destructive nature. Okay, what does that mean? Destructive nature. Now consider this example here, right? So if you want to measure the tensile strength of ropes, all right, tensile strength of ropes, right? How to do? All right, you got to test the maximum tensile strength of ropes. All right, so pull it until what? Until it breaks. And then at that point, you get what? The tensile strength of the rope. Now, you want to get what? You want to get the average tensile strength, but you do not want to what? Break every single ropes you have in order to get the true average, right? So because it has a destructive nature here. So you cannot just break all the ropes you produced and then get it simply to get the average tensile strength. So that's not good. All right. So it has some destructive natures. Now, another example, the maximum weight of a scale, of course, right? So the maximum weight of a scale. You do not want to try that out. Okay. So if you add weights to the scale and one more and 1 pound more and until it collapse, right? Until it fails. So then that's not good. Okay, that's not good. You are going to destroy it. Okay, so it has a destructive nature. Not good. All right. So there are also other reasons, but these are the main reasons. These two are the main reasons. All right. That's why we are doing sampling. All right. That's why we are doing sampling. Now, sampling, when we are doing sampling, you have to be careful. All right. Carefully design or select your sampling method. Okay. It is really important. That's why we say in a statistical study, it is important to collect a sample that is what? Representative of the population. You have to choose a sample that is representative of the population. Okay, so if you select a sample that only represents a portion of the population, that's not good. All right, that's not good. Now, in order to do so, all right, you have to what? To have a sound sampling method. All right, a sound sampling method is essential for good results in a statistical study. Or in a statistical study, this is very important. Okay, so if the sample are not collected in a proper way, okay, the results of the statistical study may be useless. Right? No matter how sophisticated the user analysis techniques are. Okay, so that's how important a sampling method is. Okay, so you have to sample it in a proper way. Okay, so now let's consider some examples here. All right, so consider this example here. If a statistics professor is interested in the average housing cost of all the students in a certain university, what should do? She or he or she, right, needs to select a sample of students from all majors proportionally to their sizes, right? So that his sample is representative, right? So that his sample is representative. So if he or she just selects students who has taken his or her statistics classes before, in this case, the obtained sample will not be representative of the population of all students. Now, because what? The statistical classes may not be required for certain majors in the university, right? So, and also her class is just not all the classes, so it do not include all the majors, right? So it is, in this case, we will say that what? It is not representative of the population. It's not representative of the population, which is all the students in this university. Okay. Now, I'm not saying that it's admittedly all right. So it is tempting for this statistics professor to select a sample from his classes, his or her classes, right? Since what, it might be easier for him or her to get the data from these students in his or her classes, right? So that's reasonable, right? It is, you know, that's the students from her class, right, or his class. So he know their contact information and so on, right? So it's easier for him. So it's tempting, but a sample obtained in such a way is not representative of the population. Okay, so this provider should not do that. Okay, so this is going to be not representative of the population, right? So we should not do that. Avoid such methods. Okay. Now here is a definition of the so-called um, 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 sampling bias. All right, sampling bias. So a sampling bias is a bias caused by a sampling method for which a sample is collected in such a way that some subjects of the population are less likely to be included than others. Okay, so that's not equally likely. Right? Some are less likely. All right, so some are less likely than others. Therefore, there is a sampling bias. Like this professor, right? So he only selects students from his class. So students who haven't taken his or her class have what? Chance 0, right? It's less likely to be selected than these students. So therefore what? There is going to be a sampling bias. Okay, so this is going to be something you want to avoid, right? It's a sampling bias. A sampling method with a sampling bias is called a biased sampling method. Otherwise, it is called a unbiased sampling method. Okay, of course, the statistics professor in the previous example, his method is a biased sampling method, right? It's a bias because it leads to a sampling bias. Some of the students are less likely to be selected than others. Okay, so here is the definition, all right? So a sampling bias, what is a sampling bias? All right, and biased sampling method and unbiased sampling method. Now, in practice, we have to be very cautious when we select a sampling method. All right, so here we introduce two biased sampling methods that are very commonly used in practice. Very common, even though they're biased. Okay, so one is called a convenience sampling, the other is called a voluntary response sampling. Sometimes they are both. All right, both can be convenient and also voluntary. Now let's consider this definition first. All right, what is a convenience sample? A convenience sample is a sample drawn from a certain subset of a population that is, all right, be careful, easy to access. All right, easy to access. It has this convenience feature involved. Right? It's more convenient to do so. It's easier to do so. Okay, so this sampling method is usually referred to as the convenience sampling method. All right, it's a convenience sampling method. Now, of course, from this definition, we can easily see the advantage of the convenience sampling method includes the following, right? So it's expedited data collection, much faster to collect the data because it's easy, right? So when time is limited, researchers tend to favor a convenient sampling method since they are quickly collected sufficient data from their study, right? So yeah, and ready availability. Okay, so often have this feature as well. Okay, so convenience, it's easy to collect. Okay, so So it's the data is often readily available from the street for the researcher to collect. And also it's cost effective in many cases because it's easy, right? So you don't have to cost much, okay? So this is also very interesting. Convenience sample. Now, even though, all right, however, all right, it has some advantages, all right, but we still have to be careful. Even though convenience sampling can be easy to obtain, that's a disadvantage. Usually, what outweigh its advantages? Okay, because what? It is a biased sampling method. The result obtained is not representative of the population. And of course, it's not reliable, right? So one major disadvantage is that the convenience are usually not representative of the population, which decreases the credibility of the conclusions about the population based on the convenience sample. All right, this is very common. All right, so in practice, you have to be really careful. All right, you have to when involving with convenience sampling. All right. Now, for instance, let's consider this example. A poster interviews shoppers at a local mall. If the poster only go to the mall on should be on, right? So on Saturday and is still on Saturday and Sunday afternoons, because those are the most convenient times for this poster. All right, poster easy, right? Easy for him, convenient. So convenience sampling method. Now this will lead to a convenient sample because it is convenient. It's easy, right? So so you need to avoid such things. If you just go there in the Saturday and Sunday afternoons, you only have these customers, right? The shoppers often go to there in this specific times. But what if the shoppers go there during the weekdays or in the mornings, right? Or at night, and so on. Right? It's not representative of the whole population of the shoppers. Okay, so of course, the result you get is not going to be decreased. The credibility is low, right? So maybe the shoppers, there are a lot of shoppers going to the mall on Saturday and Sunday afternoons, right? But during the weekdays, it can be a lot lesser. You cannot just saying that okay, the number of shoppers on Sundays and Saturdays are great, right? And you cannot generalize it to other days. Okay, so it's going to be something you have to be very, very careful. Now, do you have another example of convenience sample? Do you have one? Right? So I believe you have a lot, right? I believe you have a lot. Okay, so just think about one, right? So what is another example? Can you give another example of convenience sampling? It is convenient. All right, be careful. The main feature is that convenience sampling involves or emphasizes the easiness, the convenience, all right, obtained through this method. Right? It's more convenient to do so. Okay, so that is called convenience sampling. Like the professor, right? Statistics professor. We just discussed in this example here, right? This statistics professor, average housing cost of all the students in the university. Now he is apparently using what? Convenience sampling, right? So he just selected students from his classes, which is easier for him or her. So therefore, this is what? A typical convenience sampling, right? A typical convenience sampling. So this is, you have to be really cautious about this. Right? Otherwise, your result or your conclusion may be worthless. Okay, so. All right, so the next sampling method we introduce here is the voluntary response sampling. All right, so What is a voluntary response sampling? Okay, consider this definition. A voluntary response sample or self-selected sample consists of respondents who decide to be included in the sample. Right? This sampling method is usually referred to as a voluntary response sampling method because what? Because it consists respondents who decide to be included. Right? The respondents decides to be included. Okay. Now, it usually has the advantage of being cost-effective, fast, and so on, which is similar to convenience sampling. But you have to be careful. Here, the voluntary response sample, right, emphasize on the fact that it is a voluntary response. Okay, the respondents decides to be included or not. All right, so however, it is usually biased. Researchers usually have no control over the makeup of the sample. All right, so typical forms of voluntary response samples are the ones obtained through polls. All right, so like internet polls. All right, so every time we have the election here, right? So there are a lot of polls, political polls out there. So those are all what? Voluntary response. People who choose to respond, right? The respondents decides to be involved. And telephone polls, mail-in polls, and so etc. These are voluntary response sampling. Now, all right, so we will stop here and continue in the next time, in the next lecture. All right, thank you.